All right. We are going to get started. Thanks everybody for being here. It is so lovely to have you. My name is Brian, or BT, and I work for CSTA as the Director of Education.
Hi, everyone. I'm Shuchi Grover. I'm a senior research scientist at Looking Glass Ventures. Both of us are joining you from the Bay Area in California.
Thanks, Yuji. And tonight's session is part of a larger project that we've organized resources for this project at csassess.org. And this project involves creating a community of practice as well as a technology hub for assessments, plus this teacher literacy training. And I should note that this is supported by an NSF CS for All grant. You are at part 2 of a larger series. Today we're calling this Quality Quizzes for Quick Feedback. Thanks, Shuchi, for the alliteration. I love it. Next week we'll see you back for Misconceptions and Action Planning. And there's a related session happening in 3 weeks with guests from the Creative Computing Lab at Harvard on assessing and supporting creative work. This session, we try to, at CSTA, align kind of all of the professional learning with the CS teacher standards, which delineate what teachers need to know and do to teach effectively of K-12 computer science. And, oh, I just forgot to turn captioning on. Let me do that. Let's see. Okay. I'll do that kind of in 2 ways. All right. And this series aligns to the indicator 5F, guiding students' use of feedback. Our project has many inputs to the work. A lot of this is Shuchi's own research and outside projects. And tonight we're really leaning on a paper that she wrote for the CSTA conference, which focuses on computer science education, and it's a framework for formative assessment. We are going to suggest 2 homework readings for you, and one of those is the paper that Shuchi wrote for the most recent CSTA conference. And another one is at the bottom here. It's Yvonne Cow from West Ed created a literature review of student assessment.
Michelle says you're cutting in and out. Are others having trouble listening to hearing BT?
I'm not having any issues.
Okay, so for some folks, the audio is choppy, but for the most part, it looks like no problem. So keep going. Hopefully, it'll be all right for everybody.
Okay, sorry for the troubles. So, welcome again. Our focus is the quality quizzes for quick feedback, and these are the goals for the entire series. And tonight we're particularly focused on expanding the types of formative assessments used. And we're going to expand what we mean by type to both the what and the how, and look at those 2 axes across many different examples. And then you will get into breakouts to play and experiment. We will also be revisiting that framework for what are the features of quality formative assessment items. The order, we are going to recap session 1 in about 5 minutes, and then we are going to talk about those kind of 2 axes of types of quiz-based assessment items. And then we're going to go through lots of examples, and then we will practice together and then get to the breakouts. We had feedback last time that folks enjoyed the breakouts, so glad to hear that, and wish that there was a little bit more time. So we have extended the breakouts slightly today, so they will be about 15 minutes, and so we will be covering examples pretty quickly so that we can make time for that. And Shuchi noted in the chat window, the link to the session page on the csassess.org website. All of the resources are listed there, including the slides for today. Thanks, Shuchi. So I want to quickly recap ideas from session 1. So formative assessment is assessment for rather than of learning. And it includes both the formal and informal moves. And it's about gathering information in order to make an inference about what students can do and know. And we do this in order to both establish goals, adjust instruction, inform learning, and it's all about feedback. It's not about evaluating at a systems level or about grades. And we do formative assessment in these ways. We assess in multiple ways. It happens during as opposed to after instruction. We focus on the recipient, which is the student. It comes from many donors, meaning it can come from students themselves, from teachers, from their peers, from technology solutions from the community. It targets known misconceptions, and this will be the focus of our third part next Thursday. And it's also part of a responsive process of monitoring, diagnosing, and acting. That'll also be a focus of next week's. And last time, we walked through many different types of formative assessment and went through some different examples of them. And today we're going to be focusing on a section of those that we're calling quick quizzes. And those generally include things that have multiple choice, fixed answer, innovative types, and open response types. And we're going to be breaking that down into greater detail in a moment. We also want to recap qualities that make a strong formative assessment item. And these are that they can be done in a speedy way, that they are timely, they're in the moment, and they're also done ongoing during instruction. They're accessible to students, meaning that they're able to read them, the cognitive load is doable. They're aligned to learning goals, and that those learning goals are granular enough for teachers to understand what they know and don't know. It provides feedback and informs follow-up action for both students and teachers, and it should provide enough information to make an inference. And the last major concept we got to last time is this idea of moving from standards to granular learning goals when evaluating, designing formative assessments. So at the top, this is an example of a grades 3 to 5 programming standard. And we showed a list of some potential granular learning goals that align to that. And the idea here is that formative assessments should look at what students are able to do in the moment. And so it's choosing one or a few of these more granular goals to assess at a time, as opposed to the entire package is more of a summative item. This is an example that we looked at last week of a problem, and it is about variables and variable assignment. And so this is the middle grades standard that is aligned to that. And rather than using the standard, we want to be more precise to say, what exactly are we assessing in this item? And here it is about evaluating expressions and creating new variables from existing ones using expressions. All right. Should you anything to add before we move on to today's content?
No, all good.
Let's do it. All right. We'd love for you to jump in now and share in the chat what are types of quick quiz programming questions. What are types of quick quiz programming questions? See, Erica said Parsons problem. Donald said find the error, could debug. I see yes, no, or true or false. Multiple choice.
Predict the output. Debug.
Melissa noted like an informal one, thumbs up if you think this is a conditional statement. Great.
Tailbacks. I want to understand that, Michelle.
I see ordering or sequencing.
Yes. True or false?
Great.
Describe what this block of code does. Yep.
Kahoot type games. When I think so oftentimes when we hear these quick quiz items, we think of this this image, which is like those awful bubble sheets and standardized testing, where it is kind of just a basic question and answer. And I think the problem so often with this is it gets a really bad rap because it is just so boring to get through these. And not only is it boring, but oftentimes it feels really simple. Like this question number 3 at the bottom, a variable is what? It's really just looking for like matching a definition. So it's assessing a really kind of lowest level of knowledge recall. And that is like these items are easy, but it doesn't have to be that way. And so, one of our goals today is to gain some appreciation for what is possible in an auto scoring environment that is both multiple choice, but also a number of other types of items that can be auto scored and provide feedback. So, I'm going to go through the first kind of axis of what are some types of quick quiz items. And this is what we're calling the what. It is what programming students are engaging with, programming content. And so the types here include determining the output at the of a program, specifying what the value of a variable is during it. It's figuring out the correct solution or whether a given solution is correct. Debugging code, I heard that as one of them. Comparing multiple solutions or completing a given solution where there's like a black box or a blank. It could be transforming a solution, manipulating code, changing the representation that's given, defining the purpose for a given solution, refactoring code, or Parsons problem. So there are a lot there, but so that is one. That's what we're calling the what.
And just to clarify, when we say Parsons problem, we're talking about putting things in the correct sequence. So that's another word for that. It's a sequence problem. Sure. And the other axis is, what form is it delivered in? So how are you giving the assessment? And for this, often, of course, we have multiple choice and multiple select as the most common type, sometimes a fixed answer. But you could also have some more interesting types. You could have a hotspot interaction or a select point, which is point and click. We've talked about Parsons problem, which actually involves the student dragging and dropping something in the correct sequence. You could have matching column types. You could have code correctness, which you see very often in e-textbooks, Runestone, etc., but also on assessment platforms like Codio and Affinity. And you could have an open-ended assessment type. And as I mentioned, these innovative types that we've talked about basically push the boundaries a little bit on what can be auto-graded, like multiple choice. They're quick and in every way like multiple choice, except that they're a little more interactive. They're a little more engaging. Sometimes they lower cognitive load because there's, if you can respond right on a block of code as opposed to, A, B, C, D and matching and things like that, it's basically giving a little more, ease and facility in the way kids do things. So
we want you to think about what is this question asking students to do? So take a moment to kind of interpret the question. In all of these question examples, we've highlighted the correct answer. So you don't have to spend time don't get into the weeds here. Just think about the high level of what is this asking students to do? Then feel free to type in the chat window. What do you think this question is asking?
It's like at the level of the what that BT showed, code correctness and things like that.
This is asking students to determine the output. It's saying, here is a code segment, and we're asking students to trace the code execution and then select the result that they think that is the outcome of that code segment or that program. And in this case, we're calling this a hotspot program because students can click these defined regions that are listed by A, B, C, and D, and they click the one that is correct, and that can be auto-scored. This could be represented in different ways, so that's something we'll be playing with later.
And just to clarify, we're not thinking of the learning goal here. What we want you all to think about is today what and how, those two things that we talked about in those two previous slides. What is being assessed here, code correctness, code outcome, those things that we talked about.
Absolutely. And I appreciate you jumping in because I'm seeing the chat now. Our focus last time was on aligning learning goals. Now, for a given learning goal, we're looking to see that what and how of the type, the problem type. So here's the same problem type, determine the output of a program, but represented with a different how. So rather than it being a hotspot, it's a matching problem. So we can see in this problem, there are 3 code segments and there are 3 outputs. And it's asking to match the visual output to the code that it aligns with. And one more example of a similar innovative problem type is this is another piece of code, and it asks students to determine the sequence of printouts. And in this Parsons problem, students select the relevant options and put them into the sequence that is appropriate, and they disregard the items that are not relevant to the problem type.
So this is an example of having students assess what not assess, basically determine what the variable value will be at the end of execution of a piece of code. So it's a fixed response type. As you can see, very often it's given in other ways, but here it's specified as a fixed response. So you give a little box for students to enter the problem, the variable value. You're muted.
Thanks. Another type is identifying the solution. So in this case, the problem gives, there's a problem statement. It says like the following grid contains a robot represented as triangle, robots facing right. Which solution navigates the robot as shown in the arrow path? And so it's saying which of these is the right solution for the given problem. And so you generally select among those options. And the how here is a single choice, multiple choice item.
This one, again, we'd like you to take a look at it. You might find it familiar from last time. It was in one of the breakout sessions. So try and figure out what this program is asking people to do, students to do, not in terms of learning goals, but what type of multiple choice is this? Any responses? Trace execution, yes. A lot of the problems require, actually, if you see a lot of problems, even though they may be of different types, often require execution, tracing the code, understanding the code, yes. Outcome of the program, yes. Francis, by mistake, you've responded to me. But yes, the outcome of the program. So basically this is explaining asking students to explain the purpose of the code in plain language. You can have them actually type it out. It would be an open-ended response, which would take a little longer for you to assess, unless something can be auto-graded, using natural language processing. But it is about explaining what the program is doing. So the purpose of the program. This one is, again, it asks, I'll give you a few minutes to look at the code, but it's basically 3 sections. One is the user input, one is the repeat loop, and the last is a conditional. And so you don't have to ask them to figure out the entire program, but you could just say which part of the code is summing up the amounts or something like that, and they have to sort of click. So again, it's about the purpose of a certain section of the code.
Another problem type is determining correctness. And so in this example, it says the script is supposed to ask the user for a number and then draw that number of dashes. It asks the students to predict whether it works or not. And then if it does not work, to identify how to correct the error. And so And this type of problem is about determining whether it is correct or not. And so they have to trace that code execution in order to do that. This is the how is a multiple choice, a true or false question. And in this case, if like, how would you fix it? That's probably an open-ended, like teacher scored response.
So this one is again, why don't you all see what this program is what this question is asking students to do. It says the variable score always stays the same no matter how many times. Click on the letter on the code block that is incorrect. Sorry, I was typing a response to Michelle and I lost track. Yes, Francis, it is debugging. So another example. So, all of these examples, I know we are going through a lot of them and there's many more, are basically trying to get at this idea that you can assess a lot of aspects related to programming through these kinds of auto-graded multiple choice problems. And it doesn't have to be multiple choice or related types. And it doesn't have to always be having them coding for you to assess. They could also, it could also be assessed in this way.
And this is a new problem. It asks which of these scripts will draw a larger circle. And this is asking students to compare two or more solutions to a given problem. So it could be asking to evaluate which is correct or which is best given a specific criteria. In this case, it asks about the larger circle and which one does. The how here is multiple choice, or it could also be a type called point and click, where it's looking to see is that kind of that point defined, do students click that area, and they don't have their regions defined. This is another example of comparing solutions. In this case, it's showing, again, two different programs, and it's asking, do they give the correct, do they both display the correct sum at the end? And then it's given as a multiple choice problem. This is from the AP Computer Science Principles released items.
So this is, again, if you all want to sort of give it a moment to determine what kind of multiple choice problem this is in terms of, the kinds of programming things that we expect them to do in these kind of problems. Anybody? Of course, it is a multiple choice type. That's obvious. So this is a code completion problem. Basically, you blank out maybe one block, multiple blocks, and you ask students what would go in there in order to, in order to complete the program. And so you basically, it could be multiple blocks that you hide away, or it could be a chunk of code that you can present as options. But basically all of it, related to completing the code to achieve the goal that's specified.
And while this is a multiple choice item, it is a multiple select rather than a single select. So it's one of those select all that apply. And in this case, there's more than one correct answer.
Yeah, and typically I think multiple select are more difficult than multiple choice because students do have to evaluate all the solutions, available options in order to get the correct answer.
Another type is analyzing code execution. So this also requires students to trace the code, as we've seen in a few other types. But in this case, we're asking them to clue into a very specific aspect of the code execution. And so there are a few examples here. What will the value of the counter be when it comes out of the loop? How many times will the loop be executed? And how many times will the loop be executed if the counter was initialized to 0 instead of 1? So this could be like minor changes, and it's about the functioning of the program, but specific aspects. This is a multiple choice question, but it could be represented in different ways. fixed response is when students don't have the choices, but they just insert their own input and it's compared against the correct value. So in this case, it's just like an integer, and if it matches, then it is kind of correct or not.
Can I just add one more thing to the other
Of
one?
course.
That, over here, we've, of course, presented 3 different things that are, being assessed. So one of the things is that the same code snippet could actually be getting at different learning goals. One learning goal is how the variable is being updated. One learning goal that's being addressed here is how the repeat until loop works. One learning goal here is how initialization, impacts, the variable, the starting value of the variable. And so all of this is to say that the same code snippet could basically, touch on different learning goals, and instead of these being assessed together, maybe they could be assessed separately as and when you want to.
And Vladimir made a comment in the chat about there being different rationales for using different types of problems, and he noted that there's a problem with closed questions because if students are not invested or engaged in it, they can just kind of choose random answers and move on. Whereas if it is a kind of open response, then they have to engage, like do something more active in order to engage. I think it's a good point. This is yours, Shuchi.
Sure. Okay. So another kind of auto-gradable problem, multiple choice in this particular case, is basically seeing equivalent code, right? So how can one a solution be represented in another form? And here, for example, it's basically how you can create a multiple an equivalent piece of code using the while loop construct as a given for loop. And so this is, again, it goes to a learning goal related to loops, that you can use different constructs to achieve the same kind of goal and for them to understand how each of them operates and works.
Another problem type is manipulating code. And manipulating code is when we provide both a problem and a solution to students and ask them to analyze what happens when you change certain aspects of it. So like what happens when you replace code here with something else. And in this example, we're asking this, it's involving the random, and it's asking if we change, how could we make the more complicated appear more often? And so students have to figure out which of the values would you change in order to do that. And it's by, in this case, reducing the kind of options of random values to select from. This is another example about manipulating code, and it's saying that here's the script to create this pattern. What needs to change in order to create this pattern instead? And it is selecting the block. In this case, it's a point and click because students are selecting which of the blocks does that.
So a few seconds to determine what kind of, multiple choice, or what kind of problem this is. What's happening here? Should probably have had that list alongside to choose from.
It's a good thing for the future. I totally agree. Options
Yeah.
are nice.
Yeah, design with code, implementation, yes. So if you all recall, it was the point where you can present code can be a solution can be represented in different ways. So it's about problem solution representation. Yes, it could be about these other things, but the way we had envisioned this, it's basically the code being presented as the solution being presented as a flow chart, and to be converted to syntax in a programming language. And before I move on, there's one nice heuristic that Donald shared. He said, if a question has a numeric answer, don't make it multiple choice, have them type an answer. And I think that's a good way to think about fixed response, to take away the guesswork out of problems, to take away, lazy work, or whatever that some people have presented as issues.
And the how of this example is potentially open-ended, just asking students to create it and submit it. But it's also possible to do code correctness, where the code that students submit is kind of executed by a computer and determine whether like does it match, does the output or the result match the intended outcome. Another type of problem is refactoring code. And I saw the question earlier about what refactoring is. Refactoring is improving code structure and making it more efficient and or readable. And so some examples of that are using a repeat until or a while loop instead of a condition within a forever loop. It could be procedural abstraction. It's creating a procedure for repeated code, things like that. And so the structure of it changes, but the functionality doesn't. And so you could ask students how they can refactor code either for a specific purpose or to identify the parts that could be refactored. And in this case, the question's asking like which lines could be changed in order to reduce the number of operations that are performed. This is a multiple choice question, but you could also do something like a Parsons problem where you give the same options and ask them to put it in the right sequence and disregard those that are not needed.
Just to point here, chapter 25, for those who have the book on good habits of programming, talks about, these kinds of things related to refactoring code that we just discussed.
Should this is you.
Oh, okay. I was busy reading comments. Okay. So this is putting things, Parsons problems. Everybody has talked about it a fair bit. We've talked about it last time and this time, but it's, sequencing a set of jumbled blocks and presenting it in the correct sequence. And since programming is all about, algorithms are all about things in sequence, it makes for a great problem type. And, there's been research done by Barb Erickson and others that have shown that, the learning from Parsons problems has, reduces cognitive load and also, takes away that fear of putting together a program for the first time, especially not for the first time, but when you're a novice learner. And so this basically is an excellent problem type. And one of the things that we wanted to point out is that at least in Edfinity, where we've taken these problems from, we've been creating a repository there. You can also add distractors. And of course, that increases the complexity of the problem. And so if you want to make an easy version of it, don't add the distractors. You can add distractors. It increases the complexity, etc.
I also want to note that these are often done at the secondary or post-secondary level and less so at the primary level, but that doesn't need to be the case because really it's about like scrambled code and putting it into sequence. Which could or could not involve like structure as in like indentation or like when you're using loops, things like that. And this could even be done with manipulatives where students have pieces of paper or blocks and they're putting them into a sequence. We've seen like Lego bricks before with things written on them and stacking them into an order. So in elementary class, that would be a very appropriate way of doing a formative assessment. So this is our kind of main activity today, and we're going to be modeling one example together, and then we'll be moving into breakouts where you'll choose your team, and then go through the same process with some new teammates. So the first part of the task is to examine an item and determine what is being assessed. And in this case, we're asking, like in session 1, what are the learning goals that are being assessed in this item? Just take a moment to read the item and then share in chat. What are the learning goals? In this case, the script is supposed to create a countdown timer from 30 seconds to 0 seconds, but it's not working as expected. Click the block that contains the error. Rachel Melissa said it's debugging, and that is the problem type In this case, we're asking like, what is the learning goal that is being assessed? And the learning goal is most likely about loop controlling variables and like expressions. And you could do the problem in different ways, but we've aligned to some granular learning goals from that spreadsheet that we showed in the last session. And as we've heard from several people in the chat, thank you very much, folks. What type of problem is this? Well, it's a debugging problem. It's a finding and fixing an error type problem. And in this case, it's probably a point and click. It's a click the block that contains the error. But you could easily have this as a multiple choice question as well, where you say, select which block from the code segment contains the error. Now, the question we want you to discuss is, how could you assess the same or similar learning goals with a different problem type? So think about that kind of option that we just went through in all those examples. What are some other ways you could do that? Anyone have ideas? Ben says manipulating code, which is the one, and Mark's to me similar, code modify, which is where you say, like, if you change these values or this, then what happens? Absolutely. Erica said Parsons problem, and I think absolutely you could give, in fact, both the kind of the blocks that are involved here as well as some distractors and have them select the relevant blocks and then put them to the proper sequence. Great. So these types are excellent. I like that Laura said to leave out the expression, have them select what works. That's the completing the code problem type. And so we've identified a few options, but there are many, many, many. And so this is a visual of what a Parsons problem could look like, where all those blocks exist, but there's also some distractor blocks, and select them, put them into the right sequence. Code purpose is, rather than saying we're building a countdown timer, it's not working, you could say, here's the code. What does this program do? And that could be an open response, or it could be some sort of multiple choice type. And it could also be identify solution. So that is, which of the following solutions correctly create this timer that we've defined? And then it gives a few options and says, and then students select which one is appropriate.
I liked all the options that came up. You all exactly got what we were trying to get at all through this previous session. And hopefully you're going to take it to your breakout sessions too.
Yeah, absolutely. Okay, so this is what we're excited for you to have a chance to talk with some new teammates. And you're going to practice evaluating and kind of creating new assessment options. Here are the problem types. Here are the directions. In a moment, you're going to choose. Actually, Shuchi, I'm going to get the breakout rooms set up. Can you walk through the directions?
Sure.
Thanks.
So it's similar to last time. We've, or if you're new, so don't worry about that. We've created a shared spreadsheet. Spreadsheet has various tabs, some by grade and some by programming language or programming language. And what we want you, we again have two problems on each sheet. And what we want you to do initially is identify the what and how, which is what we discussed today. The what is, it's a debugging type, code correctness, or evaluating solutions, etc. The how is, it's a multiple choice, it's a Parsons, whatever. And also identify learning goals. And for that, you may or may not access that spreadsheet that we shared the last time, the granular learning goals. You can just type it out and specify. But we also want you to take it a step further. Like we did in this last exercise that BT just walked us through, we want you to think of alternative problem types, both in terms of the what and the how, to assess the same learning goals. Or you could use the same code segment and assess some different learning goals, like we saw in that loop counter example, where you could be asking for a final variable value, you could be asking how many times a loop is iterating. So those are different learning goals. And if you have time, basically do the second one as well. So if you want to pull up the spreadsheet, BT, and just sort of click the tabs and show them.
Yeah, so when you navigate here, you're going to be going to choose the same number of your breakout room as you join. And then on the sheet, those directions are repeated at the top, and then you'll see 2 items listed, and next to each items, there's kind of workspace for those things that you just outlined, which is like, what is the problem type? And here we've given you a drop-down menu. What is the how? And then there's workspace to just share, like, what do you think you're trying to get at in terms of content wise? And again, you can just use this from kind of the bullet point version rather than the super specific. And then spend your time talking about how could you design alternative problem types and list out a couple ideas. And get through 1 or 2 of the problems on your spreadsheet. And please record your ideas on there so others can see. Would love to hear in chat how that went for you. What did you find productive with your teams? And do you have any takeaways you want to share with the group?
That's great. That's the point of the breakouts, TJ. And I just want to also add that if you recall, BT mentioned in the beginning of this session and the last that this series is basically, going to be created into a PD in a box kind of thing. So all your feedback on these breakout activities and things like that would be very useful for us. You're in chat or also in the survey. We'd love to get the feedback. Thank you, Francis. Thanks for joining.
And because we're at 90 seconds, people feel free to still add your thoughts into the chat window. But we are close to the end, so we want to share a few notes. One is to please share your feedback with us. We have a feedback survey, and we use that to design the next one. And if you have questions that you didn't have answered, because we don't have a lot of time for questions here, add it in there, and then we'll try to work it into the 3rd session. Our next session is session 3 on misconceptions and follow-up. We're meeting at the same time just a week from now. We have a suggested homework, which we'll send in a follow-up email. It is, we referenced at the beginning, it's to read Shuchi's paper on a framework for formative assessment and a reference that Yvonne Cow from WestEd created. And then all of these resources, including the recording from tonight's session, will be listed at csassess.org. So use that as the place to go to find these resources as well as future ones. And we want to say actually, Shuchi asked me to show what that looks like, so I'm sorry. I'll show. This is the site, and that link takes you directly to a session page, and that's where these resources are listed, and we'll add the recording to this webpage by tomorrow.
Thanks so much, everyone.
Yeah, absolutely.
Feedback, thank you. I'm glad you all enjoyed the examples, the breakout sessions. It sort of gives us some ideas on how to, what to keep up with in our future sessions. Thanks, everyone.
But yeah, huge thanks. Enjoy the rest of your week, and we look forward to seeing you next week. Please rejoin us.
Good morning, everyone. Somebody wish. Thank you, Mark. Thanks, Andy. Thank you, everyone.
All right. Good night, everyone. Thanks again. See you next week.